So the product rule is what we use in differentiation to differentiate a product. And there is the corresponding tool in integration. It's called integration by parts. So let me start with the product rule, which is about taking derivative of a product. So you have two functions, u and v, both are functions of x. And I'm not writing x, just not to clutter the notations. So you have a product, you want to differentiate, the derivative is equal to u prime times v plus u times v prime. Right, the standard product rule for functions of one variable. Now, what if I integrate now both parts? If I integrate u times v and its derivative with respect to x, I know what the integral is going to be. It's going to be u times v. So that is simple, but the right-hand side is not going to simplify at all. I will have u prime times v dx plus u times v prime dx. And I end up with the formula saying that the product of two functions is equal to the sum of those two integrals. And now the idea is that you can play the game of switching from one of these integrals to the other. You can solve for one of the integrals in terms of the other. And then if what you have to solve looks like the first integral, you may consider writing it in terms of the second integral if the second integral is simpler. Right, so the idea is that you solve for, well, let's say, solve for u prime times v dx, and that is u times v minus the integral of u times v prime dx. So this is the final formula that you want to use. And it basically says that if your integrand looks like this, looks like a product of derivative and something else, then you can write it as this expression, and instead of that integrand, you get a different one. Hopefully that is simpler. And then we have to go through examples just to see how it works.